My name is Joe Hang. I am a student here at East Carolina University, and I will be discussing the OSI model. So, what is the OSI model? The OSI model, also known as Open Systems Interconnection Reference Model, is an abstract description for layered communications and computer network protocol design. It consists of 7 layers: application, presentation, session, transport, network, data link, and physical. The OSI model was originally created as the basis for designing a universal set of protocols called the OSI protocol suite. This suite never achieved widespread success, but the model became a very useful tool for both education and development purposes. The model defines a set of layers and a number of concepts for their use that make understanding and works easier. And the first layer that we'll be talking about is the application layer. In the application layer, applications are specifically written to run over the network. It also handles network access, flow control, and error recovery, and also allows applications to access network services. Some protocols in the application layer include DNS, also known as Domain Name System. It is an internet service that translates domain names into IP addresses. Because domain names are alphabetic, they're easier to remember. The internet is based on IP addresses, so every time you use a domain name, a DNS server must translate the name into the corresponding IP address. Another protocol is HTTP, which stands for Hypertext Transfer Protocol, and it is a set of rules for transferring files such as text, graphic images, sound, video, and other multimedia files on the World Wide Web. As soon as a web user opens their web browser, the user is indirectly making use of HTTP. So, HTTP is a protocol that transfers information over the internet, and it also acts as a reply and response between a client and server. The next protocol is FTP, which stands for File Transfer Protocol, and it is the simplest way to exchange files between computers on the internet. Like the Hypertext Transfer Protocol, which transfers displayable web pages and related files, the Simple Mail Transfer Protocol, which transfers email. FTP is an application protocol that uses the internet's TCP/IP protocols. The next layer is the presentation layer. It translates from a application to network format and vice versa. It is responsible for protocol conversion, character conversion, data encryption, decryption, expanding graphic commands, and data compression. It sets standards for different systems to provide seamless communication from multiple protocol stacks, and sometimes it is not always implemented in a network protocol. The next layer is session. It establishes, maintains, and ends sessions across the network. It manages who can transmit data at a certain time and for how long. It is also responsible for session checkpointing and recovery, and also it handles security of the session. The next layer is the transport layer. The transport layer manages the flow control of data between parties across the network. It divides streams of data into chunks or packets. The transport layer of the receiving computer reassembles the messages from the packets, and it provides error checking to guarantee error-free data delivery without losses or duplication. Some protocols in the transport layer include TCP, which stands for Transmission Control Protocol. and it is used extensively by many of the Internet's most popular application protocols, including the World Wide Web, email, file transfer protocol, secure shell, and some streaming media applications. TCP is responsible for ensuring that a message is divided into packets that IP manages and for reassembling the packets back in the complete position at the other end. Another protocol is UDP, which stands for User Datagram Protocol, and it is a communication protocol that offers a limited amount of service when messages are exchanged between computers in a network that uses the Internet protocol. Unlike TCP, UDP does not provide the service of dividing messages into packets and reassembling it at the other end. The next layer is the network layer. The network layer determines how data are transferred between network devices. It routes packets according to unique network device addresses and provides flow and congestion control to prevent network resource depletion. One of the most common protocols for routing information at this layer is the Internet Protocol. And the Internet Protocol is a method by which data is sent from one computer to another on the Internet. Each computer known as a host on the Internet has at least one IP address that uniquely identifies it from all other computers on the Internet. When you send or receive data, for example, an email or a web page, the message gets divided into little chunks called packets, and each of these packets contain both the sender's internet address and the receiver's address. The next layer is the data link. The data link layer acts as a protocol layer which transfers data between adjacent network nodes in a wide area network or between nodes on the same local area network segment. It turns packets into raw bits and at the receiving end turns bits into packets. It is responsible for error-free transfer of frames to other computers via the physical layer, and it consists of two sublayers, the logical link control and the media access control. And they provide reliable communications by ensuring that the data is not broken and also by examining packet address information. A bridge, for example, is a device that works at this layer. A bridge learns, forwards, and filters traffic by examining the layer 2 MAC address, and this helps segment network traffic. More recently, bridges have been replaced by switches, which performs the same function as a bridge, but it can do so on each port. The next layer is the physical layer. The physical layer is a combination of software and hardware programming. It is responsible for bit-level transmission between network nodes, and it defines items such as connector types, cable types, voltages, and pinouts. By adhering to the standard model of communications, modern networks, including the Internet, have come into existence. This standard of communication lays the foundation for all of today's modern networks, hardware and software. And this concludes my presentation. Thank you for listening, and I hope you enjoyed it.